This presentation is airtight drywall and air sealing. We're actually going to air seal before we attach any drywall. So in other words, we're going to try to create a continuous air barrier. And then the drywall is going to be part of that air barrier. But just using drywall on this wall and expecting that to be a nice continuous air barrier is going to be very difficult to do, because we have cutouts, we have holes in this wall. We have holes in this wall that lead to the basement, and some other holes that go up into the ceiling above. So all that has to be done in order for this to work. So I'm going to start out by explaining what an air barrier is. An air barrier is just a barrier that stops the flow of air through that structure, either in or out of the structure. So it has to be continuous in order to work properly. Like here, I just drew a sketch of a house. This is the ground right here. This is a basement. So where do we want that air barrier to be? Let's say we start right here on the basement floor. We're just going to follow all around up to the roof line. And in this particular home, there's an actual third story. So we're going to follow part of the ceiling up the knee wall, along the rafters, along the top, and then all the way back down. Then all of a sudden, there's a little bump out room. We got to make sure we enclose all that. So really, the point is, when I draw a line on the air barrier of this house, my magic marker never leaves the surface. It has to be continuous. In other words, if I treat this wall as an air barrier, I have to remember that what is below this is the rim joist area in the basement. That has to be tied into this air barrier in order for it to work. Typically, let's forget about the holes right now. Let's say I hang drywall on that wall and it butts down to this floor. There's very little air going to get right through this solid piece of drywall. So where is the air going to leak through? Where the materials butt against each other. And there's a lot of places in a construction site that happens. Like in this model right here. This foundation wall is a concrete wall where it hits the concrete floor. Air is going to leak through there unless that's sealed properly. This rim joist area where the floor joist is sit on that concrete wall, there's a weak link where the walls meet the rafters. And in this particular case, where part of the floor or ceiling hits this knee wall. This is a very critical leaky area. And the same thing where it hits the rafters, and the rafters hit the roof rafters up here. There's all these intersections are the key things that you need to deal with. And then on top of that, we cut all these holes in here. Like let's say this is a room with a washer and dryer. You cut a hole right in the wall to exhaust the dryer. There's an air leak. You have all these outlets in all your exterior walls. You have all these lights in your ceilings going directly through this air barrier. So we try to make that continuous and handle all these little penetrations. Now the air barrier can be in 3 different places. It can be on the outside of the house. Let's just assume that this is an outside and exterior wall. This is my plywood. The plywood is part of the air barrier on the outside of this structure. And quite often that's covered with a house wrap material, which also acts as part of your air barrier. So it can be on the outside. It can be on the inside of a wall or a ceiling as well. And that's where the spray foams come in. If you fill this with spray foam, you're creating an actual pretty good air barrier on the inside of this wall. And then it can also be on the inside of the structure, along this wall, along the ceilings. So it can be in 3 different places. If you do a really good job, it can be in one of those places and it's going to work. But I like to have multiple air barriers if possible. That way, if one fails, the other one will pick it up. So I'm going to use the drywall as my air barrier in this case. Okay, so prior to installing the drywall, we've got to get this wall ready. We've got to insulate it, we have to air seal it. If I'm going to do any caulking or foaming, I want to have everything clean. So I'm going to start by vacuuming up all this dust along the bottom plate and inside these wall cavities. You want to clean that up because I want my foam or my caulking to stick really well into all these little cracks. Probably the most ignored air leak is right along this bottom plate. It doesn't seem that significant, does it? It's right near the floor. It's not like this hole right here. It's not that visible. But you add up the linear footage of bottom plate in a house, it's going to add up to quite a large hole if it's not air sealed. The ideal way to air seal it would have been if somebody actually glued that plate to the floor prior to installing it. But I can't assume that that's been done. So I'm going to actually caulk along that bottom plate to make sure that no air is going to leak through there. So that gets caulked. This little gap between the framing right here needs a nice bead of caulking. This right along the top plate where this gap is. And this gap, you're thinking, well, that's pretty tight. Why do I need to do that? We're trying to make this continuous. We're trying to cover all the bases. Yeah, very little air will leak through there. But what if just enough does so that we have a moisture problem there and get a little rot later? We don't want the air traveling through there because the air could be carrying moist air that's going to reach its dew point and lead to moisture problems. What about holes? I have a hole down at the bottom here for electrical wire that's already been foamed. So that's made that pretty continuous. But I noticed there's one going up through that was not done. So the larger holes we're going to seal with foam. The spray foam does make a very good air barrier. So all larger gaps will have foam in them. I don't have any other larger gaps on this wall. So any holes, any penetrations, we're going to make sure you foam seal them. Now if I'm trying to create a real nice air barrier here, and I do this prior to insulating, I'm actually going to foam inside each stud cavity. And you can adjust this gun so that you get just a nice little fine bead, just like that. See, I actually see a little gap right along the bottom here. Doesn't look like much, but I'm just going to seal it.
Why are you sealing on the outside?
The question is, why am I sealing on the outside? Because that's already there. I won't be able to seal on the inside of my drywall later. If you go to this extreme, you know, you're really covering all the bases. Like I said earlier, why not? It doesn't take a lot of time. This is going to improve the performance of this building, performance of the insulation, the fuel bills are going to be lower, all because we've taken a little time to seal up every crack, every potential leakage point. So the foam is really critical. Gaps are all sealed, plates, everything. If this was a door or window here, I would caulk every gap between the framing member around there. But I've already treated a couple of outlets for other demos that I've done today. So I'm just going to stick another outlet box in. I guess right here everybody can probably see good. If you look at an outlet box, you can see it's full of holes. And even if this was a 2x6 wall, there's not a lot of room for insulation behind there. And what I used to do, I would take a piece of insulation, you know, we would just tear off a piece, stuff it behind there, you know. I mean, what's the R value of that? Like 0? It's not really doing anything, let alone stopping any airflow through there. So the key to making this outlet box or any penetration work better is to isolate that, seal right around the whole box. And that's where this little foam box comes in. This is made for a 2x6 wall. This is a 2x4 wall, so I'm actually going to have to cut a little bit off the back in order to make this work. And that goes right around, and I'm going to seal this in to make it nice and tight. I'm actually going to glue this to the wall. if there was an electrical wire, which there typically is, I would cut out a piece and then those little gaps would be foamed in. So you really isolated it. And then later on, just prior to hanging the drywall, I take some more of the acoustical sealant or a very flexible caulk and go right around that whole perimeter. So then when my drywall is fastened to this, I've really isolated that electrical box. So no air or heat is going to escape through that hole in our assembly. So this wall is pretty much ready for hanging drywall. And I made the wall airtight. Now when I hang the drywall, I'm going to make that airtight too. But before I get to that, we want to address this ceiling. It's a similar situation as that wall, only I don't have plywood on the outside of this. The only air barrier on this ceiling is actually going to be my drywall. Sometimes I will use scrap material that I find around the job site. This is what I'm going to use for my propper vent. In other words, I'm making my own propper vent. A method that I like to use a lot is if I have to buy material, I like to buy this extruded foam because it has a higher R value than a piece of plywood. So I figure I'm adding more insulation, a higher R value around that edge as well. That bay right there, I have made for this piece of plywood. You may not all be able to see, but right along this edge, I actually have a piece of foam cut that fit right tight in along that edge. That the end of the homemade propper vent is going to fit against. Put a screw in there to hold it in place. Now, some of you are probably noticing, well, it doesn't have that fit very tight. How's it going to work if it's not fit tight? I've got all these gaps. I'm going to foam that. So I put it in there a little loose. Then I'm going to take the expandable foam here. I'm going to seal all these gaps. And that's as high as I have to go up because my insulation is not going to be thicker than that. Or if it was, then I would have to go up a little higher. And now we're ready for fiberglass in that bay. I don't have to worry about the air washing around my insulation and reducing its R value. And it'd be the same thing on the other bay that I have here, only I'd be using a piece of foam. So that takes care of the wind wash. Every time you have a hole in the ceiling, you need to isolate the box just how we did in a wall. So once again, there's a nice little foam box that goes around. That just gets glued on.